Good morning. My name is Rias van Wyk. I am the director of Techno-Scan Center in Minneapolis, Minnesota, USA. Our task is to advance technological acuity. I spoke today at the Leadership Angle of the University of Stellenbosch Business School. The topic was how to stimulate economic recovery using technology-based innovation. We spoke about two tools which are becoming increasingly popular. An edited version of this presentation is available on the University of Stellenbosch Business School website. When we talk about new tools for stimulating technology-based economic renewal, we are also mindful that many of these things are happening in practice. So it's not just that we are coming from an academic point of view and saying, hey, you should be doing these things. Some of the finest stuff that's happening is happening in practice. What is the situation that we have? Well, first of all, the diagnosis of the present is we have an economic slowdown. And secondly, we have a number of initiatives around what is called a financial bailout. And then we have a number of initiatives around physical stimulus. Now, there's a difference between a physical stimulus and a financial bailout. If you think of it, that a bailout is to compensate for ineptitude. So we've seen this happen all over. We've seen the most powerful nation in the world brought to its knees through financial ineptitude. Physical stimulus is somewhat different. There we are trying to encourage the utilization of potential. And then one must ask, now, what can we do in this area of physical stimulus? Typically what comes up is what can we do to improve the physical infrastructure? What can we do to improve sustainable technologies? And sustainability has become a big thing. In many countries, there's the whole concern with replacement for foreign oil. And then related thereto, what can we do for renewable energy? What can we do to re-stimulate our technologically impotent companies? We can do many things to get innovation going. But the one thing that we'd like to focus on is technology-based innovation. And then the management need, the big management need, written in neon lights over management education, is better tools for techno-economic mapping. In other words, to take our understanding of technology and map it carefully with what is needed in business and what is needed in the economy. Where are we? Where do we want to go? And how are we going to get there? Now, when one tries to apply this to technological thinking, you immediately see the problems that face us. Where are we? What is our profile of technological capabilities? And if we have to look within companies, and we ask today in this audience, can you give us a nice, concise profile of the technological capabilities of your company? Most of us would be hard-pressed to do so. Where do we want to go? When we think of the future of technology and where we are setting targets for ourselves, many of us would think, well, are we thinking of the future of our processes of production? So that what we are looking for are new and better processes of production. That's fine, and it's great. But look at the focus that we have. It's very narrow. We talk about a 3-degree focus. Some of us would say we have to think broader than that. We have to think of our products and how our products stack up against those of competing products and of products that will be the consequence of technologies just coming along. And then some of us will say, well, why don't we think very broadly and think about possible new industries? And then we have a 360-degree focus on the technological landscape. The third step is how are we going to get there? There we must match capabilities and we must match opportunities. It's a question of looking, in the case of techno-economic planning, at looking at your technological opportunities and matching them with your technological capabilities. There are two very convenient tools. The one is called a Conspectus of the technological landscape, and the other is a set of metrics for quantifying technological progress. A Conspectus is a simple overview, and that's not strange. All of us can give a simple overview, concise overview, but here comes the but based on a unifying theory. A simple overview, but based on a unifying theory. Now, when choosing a conspectus, we are faced with a whole bunch of possible models. The first is a personal pragmatic model. That's the model that most of us use. That's the model that comes out of our native abilities, that comes out of the training that we've had, that comes out of the culture of the organization. Then there's something called the thematic model, and that's the model that I think would be recognized by you immediately. That's the model in which we break technologies down into words like nanotechnology, biotechnology, space technology, materials technology, and so on. The economic model. Now, the economic model is based on the International Standard Industrial Classification. It is formalized. It is very well formalized. In fact, we've got the Isaac classification, which gives us about 20 categories in the economy. The fourth candidate is the so-called functional model. That's when you look at technology through the basic functionalities that it provides us. And that is a very useful categorization because there are a limited number of functionalities. The functionality grid says, what are the three fundamental aspects of the physical world that we deal with? And they are matter and energy and information. And then the next question is, so how can we act on these three aspects of physical reality? And we turn to our friends in engineering and we ask them that question, and they say there are four ways. You can either process, in which case you change the inputs into a new form of output. You can transport, in which case you take the inputs and move them a distance and release them. Or you can store, in which case you take the inputs and you hold them for a longer or shorter period and then release them. And our engineers then say, and you can also inspect. But inspect really is an information activity, so we don't categorize it as there. It helps the mind of the strategist immensely to deal with technology. It is comprehensive, it is coherent, it is concise. Each of those 9 categories suggests a pathway towards technological improvement. I can improve matter processing, I can improve matter transport, I can improve matter storage, and so I can go along. So there I've created 9 pathways to technological improvement. Now, the next one that we like to have a look at is the metrics of technological progress. Because if I'm going to think about the future of technologies, I must be able to do more than merely talk about them in qualitative ways. I must be able to draw a graph. I must be able to put down numbers. And so how do we do that? Well, the first guide is to take the basic theory of technological progress that most of us know, and which breaks down into triple trends, what we refer to as the triple trends of technological progress. Do more with less, take less time while doing so, use less space in the process. The next thing we ask ourselves is, are there metrics that we can use to express each trend? And this brings us into a notion called functional performance metrics. Now, you remember the 9 cells that we had in the functionality grid? Each of those 9 cells, we can measure the change in that, and we do that with a system of functional performance metrics. And that system looks like that. We have basic units. First of all, you will see the trilogy of matter, energy, and information that you are familiar with. And then you think of these in relation to space and time. And with those 5 units, we can create a system for measuring technological progress. The do more with less translates into three ratios. Energy out in relation to matter in. Now, I'm doing this for the category energy processing. In other words, if we look at the functionality grid, look at the second level, and look at the first column. That's energy processing. So within energy processing, there are the five metrics. Do more with less, energy out to matter in, energy out to energy in, how much energy do I use to produce this energy, energy out to information in, what is the length of the algorithm required to run the energy generation plant or whatever. Take less time while doing so, energy produced per unit of time, and then use less space in the process, energy produced by the system in relation to the space that the system occupies, sometimes referred to as functional density or something similar. So for each of the categories, we have, each of the 9 technological categories, we can distinguish 5 standard metrics for measuring technological progress. So our system of metrics to quantify technological progress, we have 9 pathways to measure technological progress. We have 5 metrics for each pathway, and we have 45 generic measures of technological progress. Now, this doesn't mean that when you go out there that you want to apply all 45 measures across, or in one particular sector, all 5. You don't want to do that. But at least you have a checklist. What technological parameter do I want to use? What functional performance metrics make sense for me? And you might use 1. Typically, we use 2 when we do a techno audit within a company. What I'd like to do now is spend just a few minutes in talking about how we use this stuff when we do our scanning activity. And here is, we would call it a conspectus as a prospectus. In other words, we use the conspectus notion to think about the future. And this is a bold view of opportunities. This was done for a company that really says, let's look at what is happening out there. When we do this, we frequently start with what would be good. And what would be good, I'm going to go right into the middle of it. Output, energy, action, transport. What would be good is to be able to transport light. We are good at transporting electricity, but transporting light is a different matter. To be able to transport light, we have to do all sorts of things with light. We must be able to slow it down. We must be able to modulate it. And, you know, speed of light is speed of light is speed of light. That's what they told me in high school. No, if you beam light through certain mixtures, you can really slow it down. You can put it in and go out and have a cup of coffee, come back, switch on the device, light comes out the other side for the first time. But wouldn't it be great then if we move on to the next category there, a light battery, which doesn't mean light in the sense of not weighing much, but means that I've captured and held light. If I can slow light down like I spoke about a moment ago, and I can slow it down real slow, that means I can capture it. And I can slow it down and hold it, and when I need it, release it. Now think of the amount of energy that we use up in bringing electricity into a room like this, and all the conversion losses that we have in taking electricity into light. If we can stop light, hold it, store it, and use it, a tremendous advantage in energy savings. So that would be an example of looking at stuff when, what would be nice to have? And then to wrap up. Our task as business people is to improve techno-economic mapping. The world of technology is a world that we don't normally include in our business curriculum. We need new tools for techno-economic mapping. 2 new tools we discussed today was the technological conspectus and then metrics to quantify technological progress. And these will lead to improvement in the 3 steps in strategic planning: the techno audit, the opportunity scan, and matching capabilities and opportunities. How do you start? The first recommendation is do a feasibility study. What is feasible for us to start? Should it be training? Should it be a first technology scan? Should it be a map of our technological capability profile? What is it? And that is quite a feasible and acceptable thing to ask for. Do a feasibility study, get going. And then I couldn't resist the following: contact USB. USB has got a fantastic tradition of having the academic school, of having the business education, the executive education school, and of having the Institute for Futures Research. I mean, all of that on this campus over here is extremely wealthy. And the flexibility that they have to produce in-house courses, to produce public attendance courses, is really great. So that would be the final request. Thanks, Sion. Thank you.